Good day everyone. We welcome you to the massive open online course on cartographic techniques. So, today's class we will be actually starting with climatic analysis. So far you have seen stuff that is related to map interpretation, then slope analysis. So, now we will get into the climatic analysis. So, few climatic parameters we will see how we can analyze it with the help of few cartographic techniques that we have. So, today's topic we will be looking into how to draw a simple Windrose diagram. So, the content of this topic will be first what is a Windrose diagram, and then we will see what is the procedure to draw a Windrose diagram, and then we will look into a small example that is related to drawing a Windrose diagram, and then the major points that we should remember in terms of a Windrose diagram. Now, the question is, what is a Windrose diagram? So, a Windrose diagram is nothing but it is used to represent the wind data. So, I hope everyone are aware about wind data, right. So, in a simple term you can consider how the wind is moving. So, that you can consider as the wind data, and when we try to represent this wind data with the help of a diagram, we call that diagram as a Windrose diagram. And the major thing is that a Windrose diagram is created for a particular station, which means for a particular location you create a Windrose diagram. Now, what does this wind data contain in it? That is the next question. Wind data means there are three important things that we are going to see: the direction in which the wind is moving, the amount of time in that direction it is moving, that means the duration for a particular direction, and then the speed at which the wind is moving. So, there are three things that we are going to see here in terms of wind data, which is your direction, your duration, and the speed at which your wind is moving. In terms of Windrose diagram, what we will be discussing here is we are going to create diagrams that are related to your direction and duration. We are not going to touch speed today. I have few diagrams that I will show you how speed is represented, but for the practical we will be just trying to create a simple Windrose diagram which tries to show you which is the direction and which is the duration. Now, one major point about collecting the wind data, because initially what you have to understand is we have to collect the wind data first. After collecting the wind data only you can draw the Windrose diagram. Without collecting the wind data you cannot draw the Windrose diagram. So, in terms of collecting the wind data there are many techniques. So, I will show you few images about how wind data is collected or how we can visually have an idea about the wind data. And one major thing you have to remember is in terms of collecting the data, whatever device you use, it has to be collected at 10 meters above the ground, and in few cases based on certain applications the height at which we are collecting the data can also be increased. So, in terms of windmill, maybe at what height if we collect we can get the exact data. So, the way in which we collect the data, wind data, is also a very important thing that has to be considered. This is something which is called as a wind sock. So, you see here it is something which is called as a wind sock. Now, what does this wind sock do? So, very classical or a very important example, if you are a pilot and if you are approaching your runway, this wind sock you will find it near airports. This will give a visual idea. So, what it does is it gives a visual idea about the direction of wind and then at what speed the wind is blowing. So, if you see this sock, if it is upright and straight, it means the wind speed is quite higher, and based on which direction this wind sock is going to be, we can assume that okay, the wind speed is this much, this wind speed is this much. So, this is a complete visual interpretation about the wind data. So, in a time of emergency or in a time where a pilot is approaching his runway, this will be very helpful for him to understand the wind situation in the airport. The next one that you are seeing is something which is called as an weather station or an automatic weather station. So, this is a completely digital format. So, here we saw it is completely visual interpretation. Here this whole setup is something which is digital. So, this is completely digital, which means there is lot of data that is collected with the help of a weather station. So, you collect rainfall data, you collect the temperature, you collect what is the pressure, and along with it you also collect the wind data. I hope you can see this small setup over here. So, this is what we actually use to collect the wind data. Once you look into this image, you will understand that it will point at which direction the wind is moving, and also what happens is the automatic weather station will collect data at a certain frequency. Let us say I want to know the direction, the duration and the speed for every 1 hour, for every 10 minutes. So, you have a particular range. So, we collect the data for every 10 minutes, you can collect it for 30 minutes, you can also collect it for 1 hour, you can collect it for 6 hours. So, in a similar way, so for every particular time you can set at what time you want to collect the data. So, it basically collects the direction and the speed of the data. One major thing that you have to understand in terms of wind data is which direction is the wind coming from. That is what the Windrose diagram will actually teach you. So, always remember, when you look into a Windrose diagram, you should understand that from which direction the wind is coming. That is what you should understand. It is not at which direction the wind is going, it is from which direction the wind is coming. That is what is represented in the Windrose diagram. This is very important because there will be always some confusion when we try to look into a Windrose diagram and interpret it. You should understand that from this particular direction wind is blowing, it is coming from this particular direction. So, that is a very important understanding that you should have. And the next thing here is, so generally a Windrose diagram, it represents this wind data using a circular or a star diagram. So, in the next slide I will show you the diagram. So, in general it is a circular or a star diagram, we can tell. So, that is being used to represent the wind data. And what does it depict? It depicts the wind direction, like I said, and there is a very important term which is called as the frequency percentage for a particular site, and this is purely based on the number of observations that we do. So, I will just re-clarify to you. Windrose diagram, it represents from which direction the wind is coming, that is one thing, and then the diagram, it looks as a circular or a star diagram, and then what happens is you get the wind direction from the Windrose diagram, that is one thing that you get, and then there is a way in which we try to understand the duration part. Like I said, direction, duration and speed. So, the duration part, there is a way in which we try to understand the duration, which is with the help of this frequency percentage. So, there is a way in which we calculate the frequency or the amount of time this particular wind is blowing in a particular direction. So, the duration part, with the help of frequency percentage we will do it. And one more important thing is that, like I said, a Windrose diagram can be created on a month basis. So, like I said, if you have a weather station, if you are collecting data at a particular frequency, let us say you are collecting data at, for every 1 day you are collecting data, or for every 12 hours you are collecting data, 30 days you will get 30 different readings. So, when you try to accumulate that or when you try to average that and create a diagram, then it becomes a month wise Windrose diagram. Similarly, a season wise, so any 3 months or 4 months you can take and create a Windrose diagram for it, and you can do the same thing on a yearly basis also. So, for a particular year you can take all the data that you have collected and then you can try to accumulate it, you can try to average it, you can try to calculate this frequency percentage which I will tell you, and then you can draw the Windrose diagram. So, it is purely all based on the number of observations that we take from the weather station. And like I said, your wind velocity or your speed can also be represented with the diagram. We will not be seeing that in this class, but then it is possible, and with the upcoming of lot of digital technologies, it is much easier to represent this wind speed, duration and direction. We will be today seeing a very simple Windrose diagram. So, what you are seeing here is a simple Windrose diagram, and it is being drawn manually with the help of scale and an pencil. They have drawn this diagram. So, very basic understanding from this is, basically I can see that from the southwest direction I am getting lot of wind movement. So, the wind movement is from the southwest direction, it has been flowing more. So, a very basic interpretation from this diagram is that, and then from the northwest direction there is very less flow of wind. So, that is the basic understanding from this diagram. So, this is a more digital version. So, what you saw here is a manual version, this version is a manual version, what you are seeing is the digital version. So, this is a digital version of the Windrose diagram. So, you see here there are beautiful colors to represent the wind speed, like I said. So, see, you have wind speed here and every color shows at what speed the wind has blown, and so for this much of duration the speed is this much, for this duration the speed is this much. So, the direction and the duration is bifurcated based on the speed also. So, which speed is higher, which speed is lower. So, that information also you are able to understand from the Windrose diagram. So, this is a very basic example and this is a very basic drawing that I am showing you to understand what is a Windrose diagram. Now, in terms of the application part in a Windrose diagram, so very major application is going to be your designing of your airport runways, very major application. They try to take a data or Windrose diagrams of many number of years and they try to find out which can be the best approach for my airplane. How, if in which direction should I construct my runway completely depends on the Windrose diagram. So, based on understanding the Windrose diagrams for a long period of time, we kind of get to know how or where we should construct our runway. The next one is, it also helps the pilots and sailors also. So, they get to understand at which direction the wind will flow. So, they can adjust their execution of a flight plan or their execution of a sail plan, they can execute based on understanding the overall direction at which the wind will flow. So, it is very essential for pilots and sailors. And environmental and climate studies, so basically when you want to understand rainfall patterns, when you want to understand temperature patterns, all these things, wind always plays a major role behind it. And the next one is your setting up of wind farms. So, this is a very important example. If I am planning to set up a wind farm, if I am planning to put up a farm where I can set up my windmills, I need to know, so especially for windmills, I need to know my wind behavior, which is also again given by my Windrose diagram. And then for urban planning, architecture, especially when we try to construct high rise buildings, or if you are going to construct, let us say for example amusement park also, all these places the direction of wind plays a very major role, because let us say there are some rides in an amusement park which has a very direct impact with wind. So, all urban planning, architecturing, construction places also the Windrose diagram plays a very major role. Now, I have given you a very nice idea about what is a Windrose diagram. I have shown you how wind data is collected and I have shown you few applications of this Windrose diagram. Now, we will jump into what is the procedure to draw a Windrose diagram. So, the major steps that are involved are going to be, first thing, the collection of the wind data. So, first thing, like I said, you have to collect the wind data. Without the wind data, you cannot draw the Windrose diagram. So, the first step always is the collection of wind data at a particular station. It can be an airport, it can be a new construction site that you are going, anywhere you have to set up a automatic weather station. You can collect the wind data and then you can go for the analysis or the drawing of your Windrose diagram. So, after collecting the Windrose wind data, we go with the calculation of frequency percentage. So, I said no, for you get the direction, you get the speed also, the duration part you have to calculate something which is called as a frequency percentage. So, let us say for example, I am collecting the wind data for 1 month, which is 30 days. every hour I am collecting one observation, which means the first day at noon 12 o'clock I am collecting the wind direction and the wind speed data. So, similarly, so for 24 hours I am collecting the data, which means for one day I will have 24 observations. So, for 30 days into 24 I will have 720 observations for 1 month, and from this 720 observations what I will do is just see this formula, frequency percentage, number of observations in a given direction divided by the total observations in a given period, which is, so for my 1 month the total observations is 720, okay, and my number of observations in a direction will come on top multiplied by 100. So, for example, out of the 720 observations, if I have 50 observations where the wind is coming from the northern direction. So, what I will do is, for the northern direction the frequency percentage is 50. So, 50 observations I have seen that the wind is coming from the northern direction. So, 50 divided by 720 into 100. So, when you do this, just I will quickly go to the calculator. Yeah, so 50 divided by 720 observations into 100. So, 6.9 percentage of your data. So, it is 6.9 or 7 percentage you can consider. So, yeah, 7 percentage of your wind has come from the northern direction. This is a very important step, your frequency calculation. So, I hope you understood this step. So, the number of observations from a particular direction divided by the total number of observations multiplied by 100 will give you what is called as the frequency percentage. Now, once you calculate the frequency percentage, what we do is, so when we are going with a simple Windrose diagram, we try to give a scaled value. So, we will define a particular scale, 1 centimeter from the scale, or how much percentage does it represent. We define the scale, and based on the scale we try to calculate the final values, and based on that we draw our Windrose diagram. So, this is the major steps that are involved in drawing the Windrose diagram. We will quickly now jump into a small example. So, we are going to create a simple Windrose diagram for a given station. One step that I have done for you is, actually I have calculated the frequency percentage already. So, when in case in your exams or even most of the places you might get this data directly, and once you get this data you can go with the basic calculations. So, frequency percentage, I have also explained you what is the calculation behind, and I have also given you this particular table here. So, I have calculated the percentage and I am giving it as an input to you. And one more important thing that I forgot is, in terms of wind direction, the state of the art, or the way in which we look into direction is basically 8 different directions. Okay. So, you see you have north, east, south and west, and then you have northeast, you have southeast, you have southwest and you have northwest. So, these are the major 8 directions based on which we will try to understand the wind movement. Always in most of your Windrose diagrams you have these 8 directions. And one more very important thing is, you have something called as calm here. Now, what does this calm mean? It means there is no movement of wind, it means there is no flow of wind in that particular duration or at that particular recording. So, that we call as a calm. So, in your data you will have the 8 directions and you will have the frequencies for the 8 plus the calm, 9 different directions. So, I hope you are again clear with the frequency percentage. I have given you the frequency percentage now, and what I am telling you is 2% of my frequency I am going to represent it with 1 centimeter from my scale. So, I have 8% as frequency here. Now, what I will do is I will divide it by 2, so that I get the total distance I should draw with my scale. So, for 1 centimeter it is 2% means for 8%, what is the centimeter? It will be 8 divided by 2, which is 4 centimeters. Similarly, you will have for the northeastern direction you will have 3 centimeters. Here you will have 4.5, here you will have 8, here you will have 11, 5, 1.5, 7, 6. Actually, I am sorry, for calm you will not have any value over here. So, if you see this table I have filled it, you will see that for calm there is no value, because when we draw the Windrose diagram we will only represent the 8 directions, and how will we represent the calm? I will show you how we are going to represent the data for calm. Okay. So, I hope you are clear with this point, the scaling point. So, if I am defining the scale as 1 centimeter, 1 centimeter is equal to 2%. So, what I will do is for 8% of the frequency, what will be the measurement in the scale. So, that calculation you have to do, and then you get the final scaled value for drawing the Windrose diagram. So, once you do this, we will go for the construction of the Windrose diagram. So, in terms of the construction of Windrose diagram, what you can do is basically you can take a scale, which we do not have here, but then you have to take a scale. So, the first thing that you do is you have to represent the calm. So, how do I represent calm is basically with the help of a circle. So, I will first draw this particular circle and I will write the CALM, calm is 12, which means 12% of my wind data recorded for a particular month shows that the wind is calm, which means there is no big flow of wind. Now, I have to take a scale, place it on top, measure for 4 centimeters and draw a line facing the northern direction. So, this line will be actually 4 centimeters and I will write on top the direction, which is north. Similarly, for northeast, you will again draw a line like this and it represents northeast, which is 3 centimeters, representing 6% of the frequency. The similar way for the eastern direction, you will draw a line which is 4.5, which is your eastern direction, and then you have southeast, which is quite bigger. Okay. So, you have your southeast direction, which is a bit bigger. Your south is much bigger. So, I do not have space here. So, you know your south is a bit bigger than this line, and then you go for your southwest direction, which is again 5. So, your western direction is a bit short, which is 1.5, and your northwest direction is a bit higher. So, based on this scaling, based on the frequency calculation, we draw the simple Windrose diagram, and then you just try to join these lines with dots. The southern direction will actually look a bit more, it has to come a bit down. I do not have some space here, so it has to come a bit down also. So, this is how it will actually look like. So, this one will look a bit similar, only south I have to extend it a bit more, but then this is the overall, this is how it should look, your output when you are drawing. This is the way in which your output should look, and you can have a scale. So, I hope you have studied different scales. So, you can use any one of the scale. You can also write it like this, like 1 centimeter is equal to 2%. This is also fine in terms of writing your scale below the diagram. So, we have seen what is a Windrose diagram, I will just quickly go through what are the major points to remember. Okay. Windrose diagram, it helps to represent the direction, the duration and the speed of wind in a particular direction. And what we have seen today in terms of drawing the Windrose diagram is basically drawing based on the direction and the duration. So, if you see the diagram, what it represents is the direction it is representing, and then what is the duration, and the duration, like I said, it is taken from the frequency. It gives you the direction, duration and the speed of wind. And then the major steps in terms of your drawing your Windrose diagram is the collection of the data, calculation of the frequency percentage, scaling of the data based on what scale you want to use, and then the drawing of the Windrose diagram. And the application part, your major applications are runway orientation you have, then you have wind farms, and then you have climate studies also. So, this is all about your Windrose diagram. So, we will meet in the next class. Thank you so much.